はい。で、go back to today's class. Today's subject is about the dependability, reliability, and human error. The first part is reliability, and the second part is human error. How to improve the robot reliability? Maybe the artificial system or mechatronic system, some failure, some error sometimes happens. Yes, also, of course, in the industrial robots. Yes, so what is the definition and scale that was defined in IEC, for example, International Electric Technical Commissions. The technical term is defined by this, and also this Japan Industrial Standard shows the dependability terms in this number, the paper. What is dependability? D includes system performance, availability, the availability A, and the factor to affect is the reliability, maintainability, and maintenance support. 3 factors is there. Repairing can be repaired system, and repaired system is there. Dependability, maintainability, like this. And failure. What is failure and fault? That is a different words, technically. Failure is only the event. Failure happens, occurs. Fault is a state of the condition. Fault condition, state of failure. Now, first factor, reliability. What is reliability? Ability to perform required function under certain condition during the given period of time. が reliability の definition。で、reliability は the probability to be out of order from start to use until the certain time. It's unreliability. で、reliability is this. Reliability and unreliability, the summation of these two factors is 1, of course. The MTTF, mean time to failure, the time to making the failure event, and the time to MTBF, mean operating time before failure. Because the failure, this the duration times average time is MTBF。そういうわけで、なんだっけ、maintainability は ability to be maintained or repaired so as to perform required function while maintained in defined procedure using a certain source というのが maintainability の definition で、MTTR は mean time to restoration recover or repair ということで T とかなってます。あんまり定義を言ってもしょうがないかもしれませんが、ちょっと3 ability to be some state to perform required function until a certain time or during some period of time while external sources are prepared. Time availability is looks like this. MTBF と MTTR を足したやつがの MTBF の ratio of MTBF だし、フェイラーレートっていうのは、フェイラーレートはテクニカルターン for non-repaired system はフェイラーレートといって、テクニカルターン for repaired system はフェイラーインテンシティとか言うんだけど、that is almost the same。フェイラーインテンシティもフェイラーレートも almost the same word。で、それは、それはフェイラーデンシティファンクションがこうやってこういうふうに定義されますよと。で、リライアビリティはこの こういう定義ですよと。まあいいや、定義。No, not so important. で、for the robot。ロボットは controlled by program. Apply to various tasks. To apply to the various tasks, the program will be changed, can be changed. This is one big feature of the robot. When you change the program, one hardware can apply to many various tasks to be carried out. The various service conditions and usage environment. Because for example, the industrial robot is used in various kind of conditions. Heating condition, cooling condition, or dusty condition, noisy condition, the electromagnetic condition, and so on. Radiation condition, and so on. The system integrated mechanical, electric, control engineering, informatics, and so on. So, as I said, robot is one example, one representative of mechatronic systems. So, therefore, various kind of technical element is integrated into a system, robotic system. So, therefore, the various factors to become down to make failure. Various factors there in one system. Mechanical failure, electrical failure, signal processing failure, and so on. There are many factors, but all of the system, mechatronic system, is you remember the definition of sensor actuator. Sensor is a sensing environment. Sensing equipment to measure something in one values, and actuator by using based on the sensed signal, sensed measurement signals, the actuator is driven to move to do some work, some task, and so on. So therefore, the many sensors is equipped on the system. Sometimes it's an angle sensor, acceleration sensor, speed sensor, distance sensor, force sensor, and so on. So therefore, for example, one industrial robot has various kind of sensors. So the sensor is used to check the condition and also check the failure condition, or keep maintaining the good condition or not. Failure of industrial robots affect productivity of manufacturing system directly. Because for example, one assembling line for automobile manufacturing factory, when one robot is stopped, this line should be stopped. Only one single robot makes some failure, this manufacturing line must be stopped. So therefore, to keep the productivity in higher level, all the industrial robots, all the robots used for the manufacturing should kept the regular works successfully in a good enough condition. Becomes a serious problem from the viewpoint of ensuring safety. Because robot has some high speed, high power, so therefore compared with the human workers, so therefore when it failed or some unintended operations, it makes some serious damage in some cases. robot operates close to the human worker during teaching task. As I said, the direct teaching method is there. Look, you remember the industry. まずインダストリアルロボットがこうなんかあったとしてだよ。なんかタスクするとしてだよ。インダストリアルロボットのなんかティーチングって how to teach this robot's work。ダイレクトティーチングメソッドはワンメソッドなんだけど、じゃあダイレクト、what is a direct teaching?
Move the robot directly and the robot remember the movement, the trajectory.
ああ、ここね、そうなんだよ。こうヒューマンウォーカーがこの hold this end chip directly and operate this path trajectory by back driving this robot。バックドライブね。バックドライブっていうんだけど、だからバックドライビングメソッド directly move the end chip and present this trajectory directly by operating this end chip's position and orientation is one method。で、これを it is called direct teaching method ね。What is another way, Farid? Teaching method.
Simply use programming and manipulate forward and inverse diametrics.
ああ、なんかプログラミングなんだけど、プログラムするのは普通。What is a device to program? Computer console?
The computer console or the on-chip memory of a robot. I mean, it depends really on the platform.
Depending on the platform. But
usually the program has to reside in some memory accessed by the robot arm.
そうなんだけど、でメモリーなんだけど、メモリーはなんかこの例えばなんかコントロールボックスがあって、ここにメモリーがあって、でここケーブルがあったんだけど。なんかこうやってここにあってなんかキーがたくさんあるやつってこれなんていうの？まあそれここにエマージェンシースイッチとかあるんだけど、こうやって持ってここになんかディスプレイがあってキーがあってって和樹これなんていうの？ティーチングペンダントって知ってる？ティーチングペンダントって言うんだけど、なんかこういうなんか持って入力するデバイス、プログラムするデバイスで、こうティーチングペンダントっていうのがあるんだけどね。まあいいや、maybe next week I can show on the slide。ティーチングペンダントっていうこうツール、オペレーティングツールを使ってプログラムしてこの this coordinate position から to this coordinate position by this speed とか by this force とかなんかそういうだからプログラムロボットプログラムランゲージってあるじゃん。ロボットプログラミングランゲージでいろんな会社でそのプログラムランゲージ入力してでそれをメモリーにストアしてでこう by using this memory this robot moves this trajectory とか言ってだからこのプログラミングのツールはティーチングペンダントって言います。センサーまあこの時はalmost only the free space movement だから this point to this point for the なんか spray gun location and orientation like this for example or a sealing task the seal material is sprayed on this trajectory とかまあ mainly the trajectory is given by coding this program です。で、それの時にだからこのダイレクトティーチングの時に5 direct teaching human worker is coexisting with a robot. It is back-derived, but to make this movement freely, each motor is become active during the teaching, of course. So therefore, when some failure happens, occurs, accident happens, this human worker become dangerous condition. And also, not only the industrial situations, but also robot become more existing with human workers, such as for medical welfare conditions. So that we should reduce and cope with the failures. ということで、type of failure 1, 2, 3. One is easy to find the parts failed and easy to estimate its causality. For example, the breaking at internal wiring. Pitch wire is breakdown. Secondly, easy to find the parts failed, but difficult to presume its reason. For example, failure of electric parts. Yes, for example, some controller board failed. And in this case, controller board failure is we can understand. But which condenser is out of order? Which operating amp is transistor is failed? We cannot know, or it's very difficult to find. Which IC chip is failed? In that case, the board itself is replaced. The 3 occurred so a file, but restored later and does not reappear. これね、こういうソフトウェアバグは very very difficult in some cases because maybe it occurs only under some specific condition. But which specific condition it is very difficult to find the causality. ソフトウェアバグはちょっと難しいですよね。そう、このwhich part is I have missed is very, very difficult to find out exactly. If the very, very long coding is already established, error, flow, failure, fault in a computer program or system, which occurs only under some condition. So these conditions, find out this special condition is very difficult. So we have to check in various conditions or various parts or something. So to reduce this software bug, some method is already proposed to identify the failure source. One is record history, error history. Always monitoring, just checking the condition, and also last condition before failure, like flight data recorder or drive recorders, is very useful. What is the causality of the failure accident? For example, in case of the industrial robots, motor current is always checked, and sometimes it's always recorded. Useful not only for failure of robot, but also for faulty parts to assemble and analyze the failed task. Sometimes the assembling task is failed. Why it is failed? The robot is correctly moved, but some assembly task is failed. So why it is? We have to find the reason of we cannot achieve that kind of task. Yes, to analyze the failure, this kind of robot data is useful in some cases. And analysis method. Failure analysis and failure coping. The most simplest way and fundamental way is FTA, fault tree analysis. Main fault, top event, is here and is extended logically to its causalities using like this tree structures. This event, what is the cause of possible cause to make this event? Some first event is here, and the first event is caused by second event or some fundamental conditions and so on. By using this, this is connected with or logical symbol or and logical symbol, and estimate how frequently this fault will happen. これはフォールトトリーアナリシスです。その他にも FMEA, Fault Mode and Effect Analysis. Effect of causality on fault mode is relatively evaluated on the table by using a table ね。で、FTA は Event Tree Analysis で、これも Temporal Transition from Triggering Event to the Final Failure are expanded as a tree structure chart. This is similar to the FTA. And HAZOP. HAZOP is also the very famous method, other than the operability analysis. Abnormality of materials, information, and process flow are extracted using the guide words. And why it is even this guide words is, for example, no, not, more, less, as well as part of, reverse, other than, sooner, later, and so on. By using these keywords, we should list up the causality of that event. Is a HAZOP method. ということで、まあいいや、まず。で、フォールトアナリシスの後のカウンターメジャーですけど、The fault prevention は considering the safety operation in case of failed in advance on design. Developing failure detection function, and or failure check function, and multiplexing. Failure prevention か。failure prevention. failure prevention は prior to the failure と after accident のdivided into this. We should do the prior countermeasure to prevent failure happened. It's one important point, this part. And unfortunately, some failure, some error, accident happens. How to deal with this failure, this accident is the another way. Firstly, the design, safety design to prevent accident is the most important point. ね、それからフェイラーディテクション、フェイラーチェック、and multiplexing. Multiplexing is the some safety, keep safety even though one failure happens, one error, one accident happens. And one word, foolproof is one important word. Any human worker can deal with this task. Various operations by users, countermeasure or operating problem over long operation by users. Yes, even though the human error is there, but foolproof. Designed so as to be impervious to human incompetence, error, or misuse. The design. One is design for is important, as I said. So to improve the reliability of, for example, in industrial robots, 1, 2, 3, 4 steps. One is considering quality, file planning, and designing. The second is detailed design process, secure operation, and manufacturing quality. And third is reliability assessment. And fourth is feedback from the market, consumer. The first one, planning, concept stage. Planning concept stage. So if some product is planned, the market search and search on various standards and laws and regulations, and setting the target value, this commercial product concept, thinking, prediction of reliability and assessment of reliability. で、なんかプランナーですよね。プランナーズ、デザイナーズ work. And secondly is a detailed designer. The selection of and evaluation of parts and components, reliability design, service life design. You know the service life. Many products have some service life. It works surely, and it is credited by the manufacturer is service life. The maintenance parts is kept by manufacturer, so on. So designed service life is important. Equation of example of failures, past experience is used. The analysis by FMEA とか FTA とか and so on by using some method, the analyze prediction of error, and in some cases some part has been done durability test. And thirdly, the manufacturing stage. While manufacturing, assembling something, early stage instability control, because first starting up condition is not good, badly, and make many mistakes. So therefore, the early stage you have to take care. And process design, job instructions to the workers, and process control, process check, incoming inspection for each assembling parts, shipping inspection after the assembly, and subcontract management. If some part is developed by other companies or subsidiary companies. And fourth, sales and service stages, the quality monitor from the users, claim interpretation, claim analysis is very, very important, failure analysis, on-market processing, and these claims and these result is used to improve the next model or model itself, present model itself. So the two quality control, to do some quality control, this feedback, claim correction and analysis is very important. For example, for the automobile companies. Toyota have done it very, very surely, exactly. So therefore, it is used for the quality increasing. Yes, this is the example of the, in case of the industrial robots, driving unit. For example, in the driving unit, the product cycle, design driving unit, assuming the product cycle, and checking programs such as abrasion and durability and so on, building wiring by endurance test. And also, we have to think the regular inspection and regular repairing parts, replacement interval or periodic replacement parts, such as the timing belt or something, and lubrication instruction, the pouring the oil for driving part and so on. Structure part, strength reliability evaluation using 3D chart in design and structuring analysis based on some simulation softwares. And controller, available parts, allowance calculation against max voltage, current and temperature. Lifetime calculation, expendable supplies such as electric condenser, capacitor. Capacitor one easy to fail parts on the board, electric board. And anti-noise capacity, ECM, the durability by vibration test, thermal cycling test, and so on. And soldered portion is important. We have to check the soldered portion, surely. And software. So large scale software, presently it has become the very, very large scale. So therefore the various kind of method is there. For example, software module. So the modularization is one way to solve this kind of problem. Structures programming and waterfall models and V-shape model, many various kind of method is there to prevent the to find easily to the bugs of software. Okay. スペクションテストで、ソフトウェアモジュールっていう、ラージクオリティオンイーチモジュールみたいな、まあ、ラージスケールの場合は、なんだっけ、なんかモジュラライゼーションがone way to important。あとなんだあとそう、the divided into several modules, the specification document is very important for each modules. And the coding method should be standardized. And unit test and consolidated test is also there to check all the conditions. Difficult to estimate every failure and trouble. Required to consider possibility of unanticipated operations and hang up, for example, by spike noise or radiation effect, electromagnetic waves, in some cases. ね、なんだっけ、なんか言おうと思って忘れちゃったな。なんかウォッチドッグタイマーとかいうのを中に入れて、the insert in the large scale, in case of the large scale program, the watchdog timer is a hardware device that monitors the system health and functionality by communicating with the system software. The communication is through the dedicated device driver or device timer. In regular watchdog operation, the light service pulse, だからサービスパルスライティングとか is not executed, the system will be reset and resume a normal condition, supervising software operating using the hardware method. だからハードウェアで some pulse is always the executed and the software is read this the pulse condition, and then if the software cannot read the pulse, it should be resetted. All of the condition is will be reset and resume to the normal condition. This is one way, is to keep the condition. はいです。ということで、大体ここまでこれで、あとなんだっけ。あとはマニュファクチャリングプロセスの時には take care not to derive faulty products で inferior product to following stage. For example, the bolting task of the reduction gear, difficult to find forgetting the tight one from several bolts. これは何を言ってるかというと、例えば何を言ってるかというと、何を言ってるかというと、なんかこうさ、フランジってあるよね。フランジにこのカバーにこうあって、でここにボルト、それぞれにボルトをこう刺して止めますよっていう仕事ありますね。ここにボルトを入れてここに止めますよっていうね。でその時にまあこのカバーとフランジとボルトで、その場合にはこのボルト、このケースとここには1、2、3、4、5、6だからボルトは必ずなんかトレイに6ボルト is provided at the same time。この6ボルトケースとこのフランジケースを This set is provided at the same time。 to not to forget the screwing these 6 bolts. Is one way. So supply necessary number of bolt is one way to not to forget, to prevent to forgotten about the screwing. They provide additional work sequence such as marking after each bolt fastened. So after each bolt fastened, it is surely fastened to this hole. It should be marked like this, marking and checking this bolt completely tightened completely. It's shown by marking by the worker. Is one way. I also, when I was working for the company, firstly joined the company, all of the freshmen is go to the product manufacturing line. So therefore I have worked for 3 months, about 3 months, and then I have done this kind of screwing, nut screwing works, and making the checks, and I have asked to more fast and tightly. I have asked by the head of that groups. And the FDA. For example, this is one example of FDA of the danger of human-robot coexisting condition. Yes, what is the hazards? The one hazard is no preliminary agreement of task between human worker and robot. And also the dangerous structure is here in the robotic system. And what is the element? Human error. The robot couldn't respond to its malfunction itself, and robot malfunction. Today's one subject is to make the FDA this kind of graphs, charts. So I will show this video. This video is one example of a practical example.
Welcome to this NEBOSH Diploma question and answer session from Safety Management Consultancy Limited. I'm Steve, one of the health and safety consultants, and I'm going to take you through the questions and answers. Okay, let's take a quick look at a question. The question relates to a fault tree, and the question is worth 10 marks, and it reads, an operator is required to monitor a steam boiler. Under fault conditions, the operator is at risk from injury from explosion due to either of these conditions. A, the boiler burner being lit when operating with low water conditions, or B, overpressure. The expected frequencies of the failures that would lead to either of these effects are given in the table below. And they are for A, the boiler burner being lit, is the water level detector fails at a frequency of 0.1 per year, or an electrical fault at a frequency of 0.05 per year. For B, the overpressure, there are 3 conditions here. It is the electrical fault, again at 0.05 per year, the pressure switch failure at 0.1 per year, and the relief valve failure at 0.05 per year. Given that the operator is at risk for 20% of the time that the boiler is operating, you have to construct and quantify a simple fault tree to show the expected frequency of the top event, which is the injury to the operator. Please press pause if you'd like to have a go at this question. Okay, let's look at this expected frequency of the top event.
でだからなんだっけ、このスティームボイラーをモニターしてるんだけど、アンダーフォールトコンディションはオペレーター is risk of injury from explosion。だからリスクはボイラーエクスプロージョンね。そのボイラーエクスプロージョンは ローウォーターレベルの場合と、in case of ローウォーターレベルと、オーバープレッシャーの場合とありますよと。で、それはこの4つのフォールトタイプは、ウォーターレベルディテクターのフォールトが 0.1 per year って言ってるわけ。で、エレクトリカルサーキットエラーが 0.05 per year って言ってるわけ。で、エレクトリックサーキット、3番目がプレッシャースイッチフォールトが 0.1 per year って言ってるわけ。で、リリーフバルブエラーは 0.05 per year って言ってて、で、このイベント、このサブイベントは、これは A の場合だよとか言って、これは A と A または B の場合だよとか言って、これは B の場合で、これは B の場合だよとか言ってるわけ。で、あとなんだっけ、これ 20%。Even the operator is at the risk of 20% of the time that the boiler is operating とか言ってるんだけど、だからそれはオペレーターは 0.2 per year のなんかミステイクをしますよとか言ってるわけ。で、given these conditions, please build the whole tree っていうのがこの問題なわけです。OK? In case of this, try the question. で、after doing the question, ちょっと I will show this explanation.
Which is the injury to the operator. Please press pause if you'd like to have a go at this question. Okay, let's look to see if we can construct the fault tree for this question. Well, the first thing we need to do is identify the top event, which is the operator being injured. Now, how can the operator be injured? Well, let's look at the event below that then, which is the first level events. Now, how can the operator be injured? Well, we know that it's due to the boiler explosion from the question, but also we need the operator to be exposed. Now we need both of those conditions to happen. So we need the operator to be exposed and we need the boiler explosion. And because of that, then that is an AND gate. Next we need to look down at the events below the boiler explosion, which is the second level events. So
boiler explosion
question, and that was either it was due to low water, condition A, or overpressure, which was condition B. But the boiler could explode due to either of these. So for this, we actually have an OR gate because it can either be the water or the overpressure. So the third level events then, well, we were given them again in the question from the table. That is due to the low detector failure or the electrical fault or condition A, the low water. So that is an OR gate because again it is either the level detector failure or an electrical fault. So the overpressure condition B, there's actually three conditions. It could be due to the electrical fault or the pressure switch or the relief valve. And again, because it could be either of these, that is also an OR gate. So that is what your fault tree should look like. I think that the main thing to remember here is to make sure that you have the operator exposed. In the top, the first level event. Okay, what we need to do now is apply the frequencies from the table. So for condition A, the failure, well,
possibility,
the frequency for the level detector is 0.1 per year. The frequency for the electrical fault 0.15 per year. And because this is an OR gate, we need to add the frequencies. So to get the frequency for the low water failure, that is 0.1.
これは OR だから
giving us a frequency of 0.15 per year.
0.15 per year.
Again, for condition B, applying the frequencies to how the overpressure could happen. And for the electrical fault, 0.05 per year. For the pressure switch, 0.1 per year. And again, for the relief valve, 0.05 per year. And again, because this is an OR gate, we add the frequency. So we get the frequency of the overpressure overpressure, it is 0.1 plus 0.05 plus 0.05, giving us a frequency of 0.2 per year. Now to get the frequency for the boiler explosion, then again that is the frequency of the low water plus the frequency of the overpressure, and therefore frequency is 0.15 plus 0.2, giving us a frequency of 0.35 per year. So now we have the frequency of the boiler explosion. But from the question we were told that the operator was exposed for 20% of the time. So the frequency for the operator being exposed is equal to 0.2 per year with the 20% of the time. And to get the frequency for the operator injury, we have an AND gate here, so rather than adding them, for an AND gate we times the frequency to get the frequency of the operator injury. So the frequency is 0.2 times 0.35, giving us a frequency of 0.07 per year, which is the answer to the question. So to get your marks for this question, you need to draw a full tree that looks something like that, and calculate all the frequencies at each of the level events, and calculate the frequency of the operator injury at 0.07.
というわけで、わかりました？で、frequency estimation に this fault tree analysis is used. Possibility analysis. これは very simple case です。ということで、other なんか various software is there. なんか fault tree analysis software is there, so some of them are the introduction of the software. これは related videos is also there. And the second part, we have not enough time to explain in detail, but so therefore I will look briefly about this part, the human error. The human behavior はなんかメカニクスとコグニティブとソシオテクニカルと3つの観点から3 viewpoint is there. And based on these 3 viewpoints, some focuses, view and classification and user interface design is also there. And in case of the cognitive viewpoint, slip, rasp, mistake is one important word. Slip, lapse, mistake, and violation is the human error. And マンマシンインターフェースで SRK モデルというのがあって、Skill Based Behavior, Rule Based Behavior, Knowledge Based Behavior とかいうのがあって、Unconscious Action とか、Rule Based Conscious but Patterned Behavior っていうのと、Conscious Behavior with Abstract and Logical Thinking っていう Knowledge Based three behaviors categorized into three behaviors by ラスムッセンっていう人が、ラスムッセンってデンマークの人がいるんだけど、ラスムッセン categorize the human behavior pattern in three categorizations。で、それはなんかこの行動とかインプットとかアテンションとかリプレテクティビティとかなんとかこう3つのことがいろいろこうあってで、なんだっけで、コントロールモードはこのホルナケンっていう人、やっぱりデンマークの人がファクターアフェクティングとオペレーターズビヘイビアっていうのがあって、あと同じ人がビヘイビアコントロールモードっていうのがあって、How to deal with the human operation って言って、ストラテジックコントロールモード、タクティカルコントロールモードとオプティミズムモードとカオティックモードっていうのがあるんだよとかいうように分類してカテゴライズイントゥで、それはビヘイビアコントロールモードはこうなってますよとかってあってで、アスペクトオブヒューマンエラーはこうですけど、ヒューマンビヘイビアはビヘイビアリカバラブル、ビヘイビアパーミッシブル、ビヘイビアインコレクタブル、ビヘイビアウィズアンディテクタブルとかいうのがあるので、これがエラーですよと。そしてエラーの構造は、エンバーレメンタルファクターとパーソナルファクターとビヘイビア パーソナルインナービヘイビアメカニズムっていうのがありますよということで、まあ、こんな図式がヒューマンエラーストラクチャーがシンボライズというかストラクチャースケマタイズってステータスファクターキータスとか言ってファクターアフェクティングパフォーマンスとかヒューマンマルファンクションメカニズムとかインターナルヒューマンファンクションとかエクスターナルモードオブマルファンクションでパフォーマンスメジャーメントとかいうこういうなんか図式がラスムッセンという人が1976にプロポーズでプロテクションメジャーはカウンターメジャーはホルナゲルっていう人がやってフィジカルメソッドとかファンクショナルメソッドとかシンボライズプロテクションウォールとかアブストラクトプロテクションウォールとか言ってまあプロテクションウォールをでさっき言ったプライヤーバリアとファーストバリアっていうのがあって予防安全っていうセーフティープライヤー to the accident っていうのと after the accident happens some to reduce the injury as much as possible っていうのがありますよというのでここに次にここの unsafe behavior の中でリーズンという人が UK のリーズンという人がこのスリップ、ラスプ、ミステイク、バイオレーションintended, unintended まあ unsafety task, unsafety behavior は unintended behavior と intentional behavior があって、まあ、それはエラーと言われているのはスリップ、ラスプ、ミステイクで、まあ、バイオレーションは intended error ですということで to reduce this the incorrect operations the countermeasure はretraining redesigning of work environments support of memory good information services increasing of knowledge is education ってことですねであとはなんかパーソナルインフラクションとかバイオレーションに対してこのバイオレーションに対してはmainly personal motivation for action なんで understandable only in the society social context でカウンターメジャーは modification of attitudes raising moral it's very difficult improving culture etc. that creating safety culture is important このモラルハザードはちょっと一応 it's difficult to deal with but some education and atmosphere creating is very importantもうほとんどこれおしまいだと思うあとはなんかビデオがたくさんありますでほとんど時間がもう5分前なんでこれでおしまいなんだけど OK でインフォメーション This month from 21st Wednesday to 23rd Friday June the exhibition West Japan Manufacturing Technology Innovation Fair will be held at the ここの exhibition hall. Some of the students have already gone in the last semester. West Japan Industrial and Trade Conventional Association がここでやってますよとか言ってこれでなのでthis is the chance to get some additional score, additional point. If you bring some report after visiting this and watching this, and what you have watched, and what you have thinking, and what you have learned, fact part, opinion part should be reported clearly. I will in addition to the usual regular subject homework, if you provide after attending this event, I will give you some additional bonus point. OK? です。ので見てくださいね。